this is our line for 0.125. Okay. Then I'm going to add other lines. Okay, this is just a sketch. Okay. So we know that this is austenite. Over here is our ferrite. Over here we have a combination of ferrite plus austenite. And in this side, you have what we call ferrite plus biperlite. And sometimes you see this ferrite plus, where they put a bracket, ferrite plus what? Cementite. Okay, so you, because ferrite plus cementite is equal to what? Perlite, right? Yeah. So I start to understand how is this material been produced. Okay. So what they do, okay, they will heat. First thing, so they will heat to austenite region. Then what they do, control cool to austenite or to ferrite plus austenite region. And finally, this is followed by what? Quenching. Okay. So how this work is, they will start from 0.1. Okay. So this is 0.1. Hit to austenite region. Then they control cool to 0.2. Okay. 0.2 is what? Control cool to ferrite austenite region. And then this is followed by quenching. So when you quench, what tend to happen? So when you have ferrite plus austenite, and then when you carry out quenching, okay, now when you carry out quenching, this diagram is useless already. Okay, then you have to look at the temperature Martensite diagram or the TTT diagram. You've seen those, right? Okay. So from here, you get ferrite plus Martensite plus austenite or retained austenite. Okay. So I look at the process. Okay. Okay. So I look at the process. I realize, okay, this is what is going on. Okay. Let's see. Okay. We are going to see, let's see how the temperature. Okay. So the next thing comes to my mind. Okay. I have a question. How the holding temperature before quenching affects the microstructure. Okay. Okay. So I did not know then. I realized, okay, let's see what this is like. Okay. So I started using, you guys will, after I tell you the solution, you guys will not stop laughing. Okay. So the next thing we focus on. Oh crap, did I record? I did. Okay. So the next thing I focus on is we are going to focus on the phase diagram. Okay. And using Lever's rule. You all remember Lever's rule, right? So when I was doing this, I was in my late 30s. The last time I learned Lever's rule when I was 19 years old. What I'm trying to say is, did not use Lever's rule from 19 years old to my late 30s. I thought it was absolutely what? Useless. Okay? I thought, okay? And I was wrong. It's not useless. Okay? So I started dealing with Lever's rule. Okay, and believe it or not, Lever's rule help us solve the problem, and I'll tell you how. So at this stage, I still have not a clue what is going on. Okay, to be honest. Okay, I still don't know what is going on, why the rate, or why, depending on the batch, you can manufacture the parts, and it's at random. So we know that this is temperature again. This is percentage of carbon. And we are going to start somewhere about 700. Then you have 800. You have 900. You have 1,000. Okay. And again, I like to emphasize that this is a sketch. This is 0.1. Over here is 0.2. Okay. And then you have your 723 line. Okay. So this is your 723 degrees C. It's also called your eutectoid temperature. And then we sketch again the phase diagram. Okay. So this will be about, so I'm just going to sketch. This is about 912. Okay. Then it comes down like this. Okay. And then 0.2, 0.2, this is 0.3. Then it comes down. Hold on, I'm looking at 800. Then it comes down something like this. Again, this is just a sketch, okay? Or it's more gentle than that. Okay. So I decided to use Lever's rule. So again, anything above is your austenite. Okay. And I want to find out what is the effect of, so this is your ferrite plus austenite. So from here, I like to calculate. I just pick what will happen at 800. Okay, I just decide to choose 800. Okay. What will happen if we hold at 800 degrees C? And this material is at what? 0.12125 or 123. Sorry, the carbon is 0.123. Okay. So the carbon is at 0.123, not 125. So somewhere around here. Okay.
Hello, Eugene. I think you're muted for online.
Who muted me? Are we okay? When
Yeah,
was
now
I
we are.
muted? Okay, someone mute. Don't play with the mic. Okay, thank you. Sorry, I got it wrong. Okay, so it's 0.123 minus by 0.03 times by 100 because we're going to find austenite. Okay, so 0.123 minus by 0.03 divided by 0.31 minus by 0.03 times by 100. I get 33.2%. What do you call it? 33.2% austenite. If you want to calculate the percentage of ferrite at this stage, there are two ways to do it. Okay, so you go by 0.31 minus by 0.123 divide by 0.31 minus by 0.03. It's just linear interpolation. Okay, so 0.31 minus 0.123 divide by 0.31 minus by 0.03. So you get 66.8%. Another way of doing it to calculate percentage of ferrite, you could just do what? 100 minus by what? 33.2. The answer will be the what? The same. Okay. So out from here, right? You take this value over here. Why I took austenite? Because after quenching, right? After quenching, okay, austenite,